This series of videos goes through how to sketch exponential graphs at base A. Now, I'll start by just explaining the translations, which are exactly the same as the translations you've encountered before with parabolas and hyperbolas, for example. And then there'll be other videos that'll go through some examples. So first of all, our basic graph is in the form of y equals a to the x. Now, a is greater than 0, and you can see that basic graph here. Now, the key feature of an exponential graph is this horizontal asymptote, which is y equals 0, because your graph, your a to the x, will always be greater than 0. There is no value of x that will make y negative. Also, there is no value of x that can make y equal to 0. Now, thinking about your knowledge of logs, if I have y equals a to the x and I change it to a log, I have x equals log base a of y. Now, remembering the base of a log can never be negative, and the y is always greater than 0. Now, our general equation is therefore y equals plus or minus a to the power of plus or minus x plus or minus c plus or minus b. Now, note I put the plus and minuses there because they can be either, and the shift depends on if it's positive or negative. Now, we're going to go through each of these translations one at a time, but the key point is because your vertical translation is b units up or down, this plus or minus b, as you know from your other translations of graphs, that means your horizontal asymptote is either being translated up to y equals b or translated down to y equals negative b. So the key feature that we translate in for an exponential graph is the asymptote. Another important feature of this exponential graph is the Y-intercept, that's 0, 1. Remembering that if you have y equals a to the x and you want that Y-intercept, so y equals a to the 0 and anything to the power of 0 is 1. So that makes our Y-intercept 0, 1. That point there also translates, so it'll either move up, down, left or right, but again, every graph you do, you should be finding your y-intercept anyway, so you don't have to get too caught up in that. So as I've already talked about vertical translations, this should make sense. First of all, we're looking at the plus or minus b. Note, we're going to keep that dilation factor, that a value, constant. Now, our standard graph is y equals 2 to the power of x. So that's the graph we're going to translate, and you'll notice our translated graphs all have that 2 to the power of x in them. If I look at a vertical translation up, so as you can see with this one, we have a plus 4. That is a vertical translation 4 units up. So that means our horizontal asymptote has moved to y is 4. If instead I translate down, and you can see this minus 3 here, that means I'm moving my whole graph down 3 units. So 3 units down, and you can see my horizontal asymptote is now y equals negative 3. So the key point is that plus or minus b is our horizontal asymptote. Now you'll also notice that key point, that 0, 1, is also being translated. So when I moved 4 units up, 1 plus 4 equals 5. When I translated down, 1 minus 3 equals negative 2. Now let's look at our horizontal translations. That's with the x. just like before. So if I have plus or minus C, if it's a plus C, I'm going to move to the left C units. If it's minus C, I'm going to move to the right 3 units. Again, our basic graph is this y equals 2 to the x. If I have plus 1, that means I'm moving to the left 1 unit. And you can see that represented by this translation that you can see of your points. Your 0, 1 point is also moving to the left 1. And 0 take 1 is -1. That is our new x coordinate. Our y coordinate stays the same because we only have a horizontal shift. If we have -3, you can see that this translation is 3 to the left in regards to that 0, 1 point. If I have 0 plus 3 is 3, and you can see that that is my new x coordinate. Now let's look at our reflections. Firstly, our reflection on the x-axis, and that's that minus a to the x. That flips our graph if it reflects our graph on the x-axis. So you can see that our asymptote becomes a mirror, and every point on our basic graph flips to the other side of the axis. So that means that our y values are simply changing sign. So this point here that's a becomes -a. If we're looking at a reflection on the y-axis, we have the -x. Our power becomes -x. Now, this one's a little tricky, hence why I've got 2 stars here, because what you have to remember is that if you have y equals a to the -x, I can rewrite that with a positive power as y equals 1 over a to the x, or I can rewrite that as y equals 1 over a to the power of x, which you can see there. So if you have a negative power, what that is actually doing is changing your dilation to a fraction. Okay, so you might not have that negative power. Instead, you might be given y equals a half to the power of x, and you have to realize, oh, wait a second, that's actually 2 to the power of -x. I have a reflection in my y-axis. Okay, so when we look at this graph that I have here, you can see that your points, your x coordinates in this case, change sign. So that 1 becomes -1 because our mirror is our y-axis. So that's it for basic translations. What I'll do now is I'll record some other videos that will go through some examples of how to sketch.